Okay, next question. Which is a numerical problem here. A 600 picofarad capacitor is charged by a 200 volt supply. It is then disconnected from the supply and is connected to another uncharged 600 picofarad capacitor. How much electrostatic energy is lost in the process? Okay, we'll just see how to do this problem. You have a capacitor, call it as C1 and call this as C2, the second capacitor. You have a capacitor. It is charged by connecting it to 200 volt supply. C1, 200 volt supply. What is done? This is disconnected after getting charged. This is fully charged by this 200 volt supply and then disconnected, connected to another uncharged capacitor. Let's say this is C1, this is C2. How much energy is lost? Okay, you should know one thing. There is always an energy loss when you connect the capacitors in parallel. Okay, there is a proof for that. So what we can do is to calculate the loss in energy. How do you calculate the loss in energy? You can directly use one ready-made derived formula, that is energy loss in a general case, half C1 C2 by C1 plus C2 into V1 minus V2 the whole square. This is the loss in energy formula. C1 is given, C2 is this capacitor. Values are given. V1 is first battery voltage you can take. So it is connected to uncharged 600 picofarad. Suppose if it is also connected to a battery and after charging the capacitor is removed and then the two capacitors are now connected. In this question, only first capacitor is charged by connecting it to a battery of 200 volt. In a general case, both capacitors C1 and C2, this is connected to a battery voltage V1, that is connected to a battery voltage V2. After they get fully charged, the capacitors are removed from their respective batteries and connected together. What will be the energy loss for that? This is the formula. That is why I said, there is always energy loss, because this is the change in energy you take. Change in energy you take. That means before you connect the two capacitors together in parallel when they are charged, initially what energy they together possessed, then after you connect them in parallel, what is the energy of the system, find the difference in energy. Let's say this is the difference in energy. There's a derivation for that. Okay, but you see the difference in energy, this difference in energy is what? Initial energy minus final energy. The derivation is done by calculating total initial energy minus total final energy. Total initial energy means what? Individually the capacitor's energy, because of them getting charged by the respective batteries. Add the two energies before you connect the capacitors together. That is total initial energy. After you connect the capacitors together, there is charge sharing between the two capacitors, as a result of which individual energies may change. Therefore, after connecting the capacitors in parallel, you calculate the total energy. You call it as final energy. Already you calculated initial energy. This is final energy. Initial energy minus final energy. If you do the derivation, you will get the formula. I will not be doing the derivation here. Maybe I will do it later. You can check it out. This is equal to half C1 C2 by C1 plus C2 V1 minus V2. the whole square. That is why I said there is always a loss in energy. Why? Because initial energy minus final energy is this. It is a positive quantity. You see this C1, C2 capacitance cannot be negative. Coming to this factor V1 minus V2, the whole square. Whether V1 is greater than V2 or it is the other way around, you are squaring it. This will be a positive quantity. This of course is positive. This is also positive. Therefore, initial energy minus final energy is positive. That means there is a loss in energy. Final energy is less than the initial energy, means there is a loss in energy. But this problem, the second capacitor is not charged. So you can put V2 0. Apply it in the formula. You will get the answer. That means for this problem, loss in energy will be V square. Because V2 is 0, no, you can write it as V square. Substitute the respective values, you will get the answer. Suppose you want to do this problem not by using the formula but by using the concepts corresponding to various steps, you can do it. See, what is the total initial energy? Q square, use Q squared by 2C, 2C1. Why I am using this Q squared by 2C1 formula? When you connect the capacitors in parallel, charge will remain same. Charge will remain same. Potential difference may differ, energy may differ, but charge will remain same. So total initial energy Q squared by 2C1. Total final energy Q squared by 2, but capacitance is C1 plus C2 because they are connected in parallel. So C1 plus C2. So this is energy difference or energy loss. Initial energy minus final energy. Charge is same. Charge will not get lost. So now what you can do? Q squared by 2 outside. 1 by C1 minus 1 by C1 plus C2. Q squared by 2. C1 plus C2 minus C1 by C1 into C1 plus C2. 1 C1 will get cancelled. Because this plus C1, that is minus C1. Correct? You can write C1 V1 the whole square. Q is C1 V1, Q squared. So C1 square V1 square. Q is C1 V1 or V. We took it as V. Okay? By 2. C2 here by C1 into C1 plus C2. 1 C1 will get cancelled. So half into C1 C2 by C1 plus C2 V square. Look at this one. Suppose you are not convinced of using the formula directly, you can use the ideas. Initial energy Q squared by 2 C1. C1 is the first capacitor minus Q squared by 2 C1 plus C2. Final energy, because charge remains same, the effective capacitance when the capacitors are connected in parallel here. So Q squared by 2, 1 by C1 minus 1 by C1 plus C2. Q squared by 2, simplify. C1, this Q is C1 V1, Q square is C1 square V1 square or V square. Instead of V1 you write V because only one battery is there. Half C1 square V squared by 2, there is C2 here, C1 into C1 plus C2. One C1 will cancel. So half C1 C2 in the denominator C1 plus C2, this V square I am writing it here. This is the energy loss. This formula only I gave earlier. Okay. Now you have to substitute the values and simplify. Okay. What is the energy loss formula? Half C1 C2, 600 picofarad, 600 picofarad. Here, so unit wise, picofarad, denominator 1 picofarad for the unit I am saying. So here picofarad into picofarad, pico into pico, 10 to the power of minus 24 in the numerator, but denominator 10 power minus 6, 10 power minus 12, numerator 10 to the power of minus 24. I am just saying how to simplify the calculation. Otherwise the 10 power minus and all something and all will be there. So what you can do now initially, just look at this. 10 power minus 12 for this C1, 10 power minus 12 for this C2 is a product, so 10 power minus 24. Denominator, it is an addition. So here it is only 10 power minus 12. So unit wise, this 10 power minus 12 you can separately write. Now you can go with simply the capacitance value without that pico. So C1, C2, 600 into 600, 600 square, because C1 is also 600, C2 is also 600. 600 plus 600, 1200. V square, V how much? 200. So 200 square. You simplify this. 10 power minus 12 is there, don't forget it. Okay? So half 600 into 600 by 1200 into 200 into 200 into 10 to the power of minus 12. Okay, this will be 2 and 2. This is 4, 150 probably. Okay, then 150 into 2 into 2 into 10 to the power of 4, 10 to the power of minus 12, because there is one 10 power 2, there is one 10 power 2, 10 power 4, 2 and 2 alone I have taken, this is 150. So this will be 4, 150, 600, again 10 to the power of minus 8 joule. This you can write as 6 into 10 to the power of minus 6 joule, or 6 microjoule is the answer. Micro 10 to the power of minus 6. Here in this question only first capacitor is charged. Suppose in the problem which you are going to face, if the second capacitor is also charged by a battery of voltage say V2, so it's better to remember this formula, V1 minus V2 the whole square. If they say that second capacitor is not charged, make V2 0. You will get this formula. In multiple choice question and all, that time you don't have to be working out all this. Simply directly in that time, if you are doing some MCQ, that time you will not be using concepts and all. It will take time. Directly apply it to the formula. Of course, calculation you will have to do. See to it how easy you will make the calculations. How can you make the calculations very, very easy? Manipulate the numbers and you can see it. Do some guesswork also, proper guesswork. Then finally you will arrive at the answer. But here you can neatly do the calculation 6 microjoule. Okay? Understood it? Thank you.